Hi, everyone. Thank you so much for joining us for our session on organizational success with Google Cloud, including best practices on resource management, IAM, and billing. My name is Lauren, and I'm the content manager for the Google Cloud community. Joining us today are Kamiya and Cris from the Google Cloud Technical Account Management team, who will be taking us through the content today and answering your questions. So if you do have any questions, those are encouraged. So please feel free to add them into the YouTube chat box, and we'll be sure to get to them either in the chat or at the end of the presentation. We also received a few pre-submitted questions through the registration form, so we'll be going through those first as well. Any questions that we don't get to, we will be posting a recap blog in the Google Cloud community with resources, the key takeaways, and information from this session. So we'll be sure to include any questions that we didn't get to in that recap post. And the link to the community is in the YouTube description, so you can check that out there. All right, that's enough from me. I will hand it over to you to take us through the content today.
Thanks, Lauren. And hi, everyone. The topic for our webinar today is organizational success with Google Cloud. And if you've ever wondered, how do I start my journey on Google Cloud? Or in fact, you're very well versed with some other cloud providers and are looking to kickstart your GCP journey, you've come to the right place. So this session, our agenda today really will be to cover the building blocks of Google Cloud. We'll start with resource management, move on to access management, then cover cloud billing, followed by a live Q&A session. And in each topic, we'll also cover some best practices and design considerations. So before we deep dive into the topic, I would like to again properly introduce myself. I'm Kamiya Sargoch, and I've been in technology, working in technology for 13 plus years. 5 of those have been in cloud. I work primarily with healthcare life sciences customers in Google Cloud. And in my past life, I've been a data engineer and a data analytics modeler. And with that, I will pass it on to my co-presenter, Cris.
So, hi, I'm Cris. I'm going to be co-presenting this webinar today with Kamiya. I'll take over a little later near the back half of the presentation. So I'm a certified associate and professional cloud engineer. I have experience working with multiple Fortune 500 companies that are using GCP. In my current role, I aim to help customers with their cloud journey. I have past and present experience in software engineering.
Thanks, Cris. So let's jump right in. Resource management. What is resource management? It's all about organizing your cloud resources, supporting in a way that supports your organization and your cloud ops model. And really to say a well-designed hierarchy simplifies what your access management is going to be like, how your cost control would look like, your security, your operations, and potentially reduce the complexity that comes much later and reduce the errors. So if you're thinking, yes, we want to have simplified access management, we want to be able to apply policies consistently, easily, we want to reduce complexity, and then properly designing how your resources are organized and managed will be key. So let's look at the components of the Google Cloud organization hierarchy. We have right at the top the organization, then the folders, then the projects, and then the resources. Organization is your top level component to which all other components are linked. Folders are used to group similar projects for consistently applying policies. These are optional, but highly recommended. Projects are where your resources will exist, like your VM instances, your BigQuery, your Cloud SQL. So we're going to dive into each of these components a bit more now. Like I said, organization is really your top level component in resource management. It's the root node, it's the hierarchical supernode of your projects, and it's closely associated with the Google Workspace or Cloud Identity account. Organization also allows you to effectively manage all your resources centrally and apply policies across all your resources. For some products, like for your cross-project communication, you need organization like a shared VPC. So shared VPC will allow you to communicate resources from multiple projects to common VPC network, so they can communicate securely using internal IP addresses. And for that, you need an organization in place. The next component in this hierarchy is the folder. And the main purpose really of having folders is to group similar projects for consistent application of policies. Recommendation is to start simple with the structure of the folders. They can go up to 10 levels deep, which is the hard limit, but we normally see up to 4, and that is sufficient. With folders, you want to model access patterns and not necessarily your organization hierarchy. To summarize, you want to decide on a folder structure in line with how your policies are applied, and really just keep it simple. And finally, we come to projects. Projects contain your resources, and there's a complete separation between projects. Most of Google Cloud resources require a project as their parent. And projects are useful to group related resources from a functional and access standpoint. It's recommended to have a large count of projects based on your workloads. We look at more design considerations as we go along, but overall, a good design of your components will allow for simpler operations by leveraging inheritance to reduce the number of individual configurations you might need to apply. When we talk about policies in Google Cloud, they really encompass 2 policies. The one in green here, which is IAM policies, and the one in red, which are the organization policies. And they're both used to control access to Google Cloud resources. However, they both work in a bit of a different way. IAM policies, they attach to individual users, groups, or service accounts. They control what those users can do with the resources they have access to. For example, an IAM policy could be used to allow a user to read a specific file, but not write to it. Organization policies, on the other hand, are attached to the resources themselves. They control who has access to the resource and what they can do with it. For example, an organization policy could be used to allow anyone in the organization to read a file, but only allow certain people to write to it. Now, policies are inherited in a top-bottom fashion. With organization policies, you can restrict some configurations, and we will talk about it in the coming slide. If I have to summarize this, I would say a correct organizational hierarchy design will have a tremendous impact on your operations by minimizing your touch points for IAM, for logging, and really establishing also a shared baseline for billing intelligence. So identity and access management, it focuses on the who and lets the administrator authorize who can take action on specific resources based on a list of permissions. Organization policies, on the other hand, they focus on the what and let the administrators set restrictions on specific resources to determine how they can be configured. You think of organization policies as centralized guardrails across your Google Cloud resources. And they can be really applied at 3 levels: the org level, the folder level, and the project level. And these restricting configurations, they are based on a list of constraints. And so let's look at the 2 examples here. Constraints/compute.vm external IP VM external IP access. This constraint really restricts your VM to be able to use any external IPs. Now let's look at the other one, constraints/gcp.resource location. If you want to restrict where the physical location of where your Google Cloud resources are going to be, this is the constraint, the organization policy constraint to apply. There's a long list of constraints available on our public sites. There are also constraints available for specific services like cloud functions. You can define the allowed ingress setting for the deployment of a cloud function. You want to allow HTTP traffic from public or private sources, or only from private sources. You can do that with these organization policies. With that, we are going to quickly jump into some design considerations around how to name resources and then best practices around project organization. One pro tip here is to plan your naming convention before starting to create resources on Google Cloud. This is really going to be key for your governance and operations later on. So this is the example, a good example of how to name a resource. If you look at numbers 1 to 6 here, we cover the resource type, which is PRJ, it's a project. Then we cover the company prefix for uniqueness, CMP. Then we're looking at the environment, which is PRD, production. Then we're looking at the team or business unit, could be the networking team, NET. Then you look at the descriptive name, what is this being used for? Is this a landing zone? And then the progressive ID. So proper project design and naming, it's going to be a first step towards easy cost attribution and then easy chargeback also for your finance teams. So now let's look specifically at design considerations when naming projects. Projects have 3 attributes which help to identify them: project name, project number, project ID. The key to focus here is project ID. Project ID is user assigned. It's globally unique across all GCP customers, and it cannot be changed. So that's an important decision to make. Some of the best practice there is to ensure the uniqueness of a project ID by prefixing with the company name. And also, don't use any attribute that might change later. If a team name is going to change later, don't use that in the project ID. It's important to have a consistent naming ID throughout your organization. So let's look at the design considerations to follow when breaking down resources and workloads to projects. All these considerations, when building projects are really correlated. What is your blast radius going to look like? You don't want to have a compromise on one operating environment impact the other. Then what are your quotas and limits look like? Since they applied on a project level, you don't want to have undesired, you don't want to have a dev project consume all your quota. How do you want your administrative complexity to look like? You want to break it down in a way that would really ease your IAM management to achieve least privilege access. How does billing isolation look like? And Cris will cover that a bit more on the cost control topic in billing. And then separation of duties. And lastly, really the operating environment. We want to achieve all of this for different environments by separating accordingly: prod, test, dev, staging, UAT. So what are the patterns that we see in organization design? This is a common pattern that we see when one project is created for each app and environment. There's a sales dev, there's a sales prod, there's a finance dev, there's a finance prod. Separation is granular enough to the level of a workload and duty. And then I want to share another example that we see to understand what are the trade-offs in building these organization hierarchies. This is really good from a security standpoint, as it allows you to centrally apply policies on all projects of a specific operating environment. For example, you can disable all external IPs on all VMs in a prod. It's also good from an automation standpoint, as traversing between operating environments is much simpler. With that, a recap of resource management. We've finished with our section 1. We covered resource hierarchy, the building blocks around the components, organization, folders, and projects, and some best practices around resource management. Now I'm going to dive into access management. It's a broad topic. It covers authentication, authorization, and auditing. We will touch briefly in this session on authentication of cloud identity, but we'll be focusing on authorization. That's a set of permissions that a user is allocated post-authentication. A user can be authenticated, thus confirming their own identity, but authentication on its own will not provide a set of permissions. So we'll look into IAM roles and how that really, sets you up to provide these permissions we are talking about. And lastly, auditing, which is a form of monitoring the resources accessed or modified by a particular identity. We have cloud operations, audit logging for auditing in Google Cloud. Access management and resource management, they're tightly correlated. Under resource management, we discuss the resource hierarchy, and here we'll discuss the IAM topics and how they can be applied to the resource hierarchy that we spoke about. So our objective here with IAM is to ensure that only the right people and services are authorized to perform the right actions on the right resources, and achieving all this in a maintainable and manageable way. We'll cover IAM, we'll briefly touch upon service accounts and best practices. So cloud IAM essentially means who can do what and where on Google Cloud. If you look at the who here, it could be an org domain. It's not just a user. It could be an org domain. It could be a single user. It could be a group of users, and it could be a service account. In cloud IAM, the permissions to access a resource, so the where here, the folder, the project, and resource, that's not directly granted to the end user. Instead, all the permissions are grouped into roles, and roles are then granted to authenticated members. So when an authenticated member attempts to access a resource, Cloud IAM will check the policy to determine whether that action is permitted. And IAM lets you set policies at the org level, the folder level, the project level, and the resource levels. These allow policies, as we spoke about a bit in the resource section, are hierarchical. They will propagate down the structure. So the effective allow policy for a resource is really the union of the allow policy set at that resource and then the one inherited from its parent. Let's look at IAM role a bit more in detail. IAM roles are really a set of related fine-grained permissions. When assigning these IAM roles, it's important to consider the principle of least privilege. What that means is essentially that users should only be given the amount of access that they need to perform their job. The example here is of a role called storage object admin, and it has a list of permissions. And this really, think of a scenario where you have many users, a very common scenario where you have many users uploading files to a bucket. These users shouldn't be able to read or delete any of the files uploaded by other users. But your data processing expert, that person should be able to read, or that user should be able to read and delete uploaded files, but they shouldn't be able to delete the bucket itself because the users are uploading files. So that's where least privilege comes into play. You would grant the role of storage object admin to this data processing expert, and this object admin rights would give them the access to the bucket to read, add, delete any objects in the bucket, but not the right to delete the entire bucket itself. Whereas the storage object creator role, you would grant it to the users that are uploading files to the bucket, but they can't pretty much do anything else to other files. So there are three types of IAM roles available. There are the basic roles, which includes your owner, editor, viewer roles that existed prior to the introduction of IAM. You might also see these listed as primitive roles in some of the older documentation. Then there are the predefined roles, which provide granular access for a specific service and are managed by Google Cloud. We spoke about the storage admin role, and that's an example of a predefined role. And then there are the custom roles, which provide granular access according to a user-specified list of permissions. So these are some organization level roles that we have. The two callouts here, org admin, it's only able to assign roles, not operate on resources. They can, of course, self-assign to do that and escalate your permission to do that. But by default, it's not a super user. And second is default roles. When you create an organization resource, two roles that I would like to call out are default roles, and you can see more in our public documentation, are the project creator and the billing account creator role. And a lot of times, you see based on your governance, you may not want to give the billing account creator role to everybody in the organization. So you can remove that default role from your domain and assign it to a group of users that are really going to control, your finance operations. Highlighted in yellow, these are some commonly granted predefined roles. And now I'm going to jump to IAM conditions and then service accounts, and then hand it over to Cris for custom roles and billing. IAM conditions, they are a way to control access to Google Cloud resources based on the attributes of the request. So what does that mean? With IAM conditions, you can choose to grant principals access only if specified conditions are met. And there are two kinds of, attributes that you would see there: resource attributes and request attributes. With the request attributes, if you look at the slide here, it's time limited access based on request attributes. So you can only allow access during specific working hours. You want to only allow access from a corp network. You can define this using these attributes. And then there are resource attributes. You want to only allow specific set of resources with like the resource.name.starts with projects, buckets, and then the prefix that the bucket is. So you only want to allow access to some VMs that are prefixed with a web app front end only. So those are all things that you can control with IAM conditions. Custom roles, and as opposed to the Google managed predefined roles, with custom roles, they're user created and they're managed roles with a custom set of permissions, allowing you most control over what a user can and can't do. They can be created at the org level or the project level. And lastly, service account management. Service account management, it's an entire discussion on its own, but just very briefly, these are specialized accounts whose identity is managed by VMs and apps to authenticate to Google Cloud APIs. Apps can then use service account credentials to authorize themselves to a set of APIs and then perform actions within the permissions granted to the service account. So what does that mean? Simply put, there are special types of accounts used by applications and services. And there are three different types of service accounts: default service accounts, Google managed service accounts, and user managed service accounts. With default service accounts, when you enable or use some Google Cloud services, they create some user managed service accounts that enable the service to deploy jobs that access other Google Cloud resources. These are known as default service accounts, and they primarily exist for new users of the platform who are just beginning their GCP journey. A tip here is you would see the constraints/IAM.automatic IAM grants for default service accounts. When a default service account is created, it is automatically granted the editor role on your project. This role has a large number of permissions, and to follow the principle of least privilege, you disable this automatic role grant by adding the disable automatic IAM grants for default service accounts constraint listed here to your org policy. Next is the Google managed service accounts. Some Google Cloud services need access to your resources so they can act on your behalf. And for an example here, when you use Cloud Run to run a container, the service needs access to any PubSub topics that can trigger the container. So to meet this need, Google creates and manages service accounts for many Google Cloud services. These service accounts are known as Google managed service accounts. You might see them in your project's IAM policy, in audit logs, or in the IAM page also in the Cloud Console. User managed service account, lastly, these are service accounts which are managed and secured entirely by the user and will be the type of service account which might be used in a majority of your use cases. For example, consider a VM hosting an app that receives files and then puts those files to a Google Cloud Storage bucket. The VM hosting the app will be associated with a user managed service account, and that service account should only have the IAM permissions to create objects in the storage bucket. And with that, just a quick note that there are different ways of managing and accessing service account credentials. We'll not dive into keys in this webinar, but that's something that you should look into before using service accounts. I will now quickly discuss some best practices. I think we've covered them in the webinar, but using for IAM, using groups and mapping IAM policies to functional identities is really a best practice. You should sync your groups from your source of truth so that your join and leave process is shared, and really enforce a naming convention for your group names as well. You use projects to group resources that share the same trust boundary. You minimize the points where IAM policies are applied by leveraging folders. You use the security principle of least privilege, and then you can audit your allow policies to ensure compliance. These are some IAM policy intelligence tools that Google Cloud has that we've listed here. And now I'm going to hand over to Cris, who's going to take us home with how to create custom roles and using the Google Cloud Console.
Awesome. Thanks, Kamiya. So in this section, we'll go over exactly how to create custom IAM roles with a brief demo using the Google Cloud Console. So as mentioned before, custom IAM roles are when the predefined roles just don't cut it and you want a more granular role for your users. So before we start our demo, there are a few things you should be aware of. First, the user creating the custom role must be granted the appropriate role to do so. So if you're creating the custom role at the organization level, you must be granted the organization role admin IAM role. To create the custom role at the project level, you must be a role admin. It's important to note that you should only grant this role to a small number of highly trusted users. If a user is a role admin, they can add any permission to any custom role within the project, which means If that user is granted any custom role, not just the one that they create, they have full access to add permissions to that role, giving them essentially unlimited access to GCP resources. Next, if you seem to be missing a desired permission when setting your custom role, ensure that the corresponding API is enabled for that permission. For example, if you want to add a Kubernetes engine permission to your custom role, ensure that the Google Kubernetes engine API is enabled first. So speaking of permissions, there are 3 levels of support for adding permissions to a custom role. The first is supported, means the permission is fully supported in custom roles. The second is testing, which means the permission is still in testing for compatibility with custom roles, and these roles are not recommended for production use. And the third is not supported, which means the permission is not supported for use within custom roles. So moving on to our demo, there are 3 methods for creating custom IAM roles: Cloud Console, the Cloud Command Line interface, and via the Cloud API. So today, I'm going to demonstrate the creation of a custom role through the Google Cloud Console. So to get to the Cloud Console, you're going to go to console.cloud.google.com. If you haven't created a project before, he'll prompt you to create a project, and then you'll see a page kind of like this. So I made a test project. The next thing you need to do is navigate to the IAM and admin resource, and then click on the roles section. So once there, you'll see the following screen. So currently, you'll be able to see all the GCP managed roles and which products they align to. At the top of the screen, you'll see the Create Role button, and this is where you're going to go to create your own custom role. So once you click the Create Role button, like I just did, you'll see the following screen. So I've decided to create a custom role that's a subset of an existing role. So I give it the name BigQuery Job Creator, just a normal descriptive name that describes what this role does. And then the description describes the use of the role. And then I also specify the role launch stage. Since I want this role to be immediately available to users, I chose the general availability stage. There's also an alpha and beta availability stage. And then to add permissions to the role, you click the Add Permissions button at the bottom. So an easy way to find permissions to assign to your custom role is to build your new role off of the existing GCP role. So in this case, I want to build a role that contains a subset of the BigQuery job user role that's already created and managed by GCP. So I filter permissions based on that role. So note that this is also just a good way in general to see which permissions make up a role. And then so here you can see that the 4 permissions that make up the BigQuery job user role. So as you can see, 2 of the permissions are fully supported to be added to custom roles. 1 is in testing, which means it can be added, but that role should not be used in production. And then 1 is not able to be added to custom roles by not applicable. So for this role, I just want to give a certain users the BigQuery jobs create permission without the other permissions that make up the regular job user. So I select this role from the dropdown and click Add. So once permission is added, you'll be able to see it in the Assigned Permission section. And once you're happy with the permissions you've added to the role, click Create. Once the role has been created for you, you'll be able to see it under the Role section in IAM and Admin, and you'll be able to assign this role to your users. And that's it. That's how simple it is. So in this section, we covered how to delegate and control access to your GCP resources using IAM roles, the best practices in making use of service accounts and groups to maintain the very important security principle of least privilege. We'll get back to that a little later. And how to create custom IAM roles using the Google Cloud Console. So the last section we'll be covering today is cloud billing. So we'll talk about how to set up, monitor, and control billing accounts for your organization using Google's best practices. So billing account is set up in GCP and is used to define who pays for a given set of GCP resources. Since cloud billing is a resource unto itself, access control to them is managed by cloud IAM roles, just like any other resource. So to use most GCP resources, projects must be linked to a billing account. The project can be linked to one billing account, and this linkage makes the project billing enabled. And costs on that project will be charged to the linked account. And then projects can also be separated in org nodes as shown in the slide. Disabling billing in a project is equivalent to the removal of this link. All charge activity stops when this happens, and that means these resources will stop functioning if they are billable resources. So be careful when disabling billing if it's a very important resource. So there are 2 types of billing accounts. The first type that we'll talk about is self-serve. This means the payment instrument for this is a credit or debit card or a direct debit, and the costs are charged automatically. And you can sign up for these online just you could go on today and sign up for them on the Google Cloud Console. The second is invoice. That means the payment instrument can be a check or wire transfer. Invoices are sent by mail or electronically, and you must be eligible for invoice billing. And then invoice billing is usually reserved for customers that have been registered for over a year. So an organization that have been registered over a year, and whose monthly spend on GCP is greater than $2,500 for the last 3 months. So to grant or limit access to cloud billing, you can set up a cloud IAM policy at the organization level or the billing account level. GCP resources inherit the cloud IAM policies, as we've discussed before, of the parent node, which means you can set a policy at the organization level to apply to all the child billing accounts in that organization. So no need going to every single billing account. So this is an example of the single billing resource hierarchy for an organization. So in this example, there's a single organization with a single billing account. Now, these billing accounts are linked to all projects in the organization by a user with the project owner and billing admin roles. So the pros of this are centralized visibility and control, shared technical implementation and practices, and centralized visibility and control in overall spending in just general, since you only have one billing account for all your projects. So you don't have to go manage different billing accounts. And that's kind of the whole pro of this whole thing, is having one billing account to manage and one billing account to look at. So the use of a single billing account for a GCP organization is Google's best practice for setting up billing accounts. Now we have the multiple billing accounts for one organization. So please know, as said before, Google recommends the use of a single billing account as much as possible. The reasons for this is it's easier to control the single billing account and gives everyone greater visibility of an organization's spend on GCP. And having one account eliminates a lot of headaches down the road for having to manage multiple accounts or merge them or drop ones and switch to another, anything like that. So if you're considering a multiple billing account strategy, you should carefully consider whether or not you actually need to use multiple billing accounts. So some common use cases for multiple billing accounts are for resellers, using resources that require payment in a different currency, companies with a legal entity in another country that have maybe different tax requirements, or if you're a large multinational organization with multiple organizations and billing accounts. But again, for most use cases, we strongly recommend the use of a single billing account for all your organization's spend with GCP. So here in this example of the resource hierarchy with multiple billing accounts. In this example, we have a single organization with multiple billing accounts. And then, as we talked about with isolation, entities and affiliates are separated in a folder structure with isolation and security mechanisms in force. Different billing accounts are assigned to each entity, which maintains billing isolation, so one entity can look at the billing of another entity. So the pros of this are, as said before, centralized visibility and control, and shared technical implementation and practices. But the cons of this are managing multiple billing accounts. So that's the basics of how to set up a billing account on GCP with both multi-billing accounts and single billing account approach. Now, let's look into how to monitor and analyze our spend with GCP. So one of the most important best practices that I can give you today is to set up billing export to BigQuery as early as possible. This will provide you with a clear understanding of your spend on GCP from the beginning with clear indicators on where you're spending the most of your money on GCP. This is a critical step to capture data on spend. Setup is simple, and the procedure to do so is well documented. Export to BigQuery is recommended, and you can leverage analytics and visualization all within the same GCP environment. All you have to do is choose a billing account to export the data to, and then export it into a selected project. So this is an example of what a final billing visualization can look like by leveraging the power of just two GCP tools, BigQuery and Looker Studio. In this example, the usage and billing reports of cloud storage and compute engine are exported into BigQuery where it can be quickly and automatically visualized with Looker Studio. This will create, as you can see in the slide, clear charts, tables, graphs, and you can see how your cost trends change over time. So to wrap up, I'm going to cover some final topics that everyone should know when it comes to cloud billing. The first is labels. So there are two types of labels. We have project level and resource level. So a label is a key value pair that helps you organize your GCP resources, such as instances. You can attach a label to each resource then filter the resources based on their labels. Information about labels is forwarded to the billing system, so you can break down your billing charges by the label. This is useful for tracking and chargeback purposes. In terms of billing, you should be adding labels to your GCP resources by team or cost center. So when you get your billing report each month, this will allow you to easily distinguish who owns what resource. Now let's get to billing reports. Billing reports, they are complementary to BigQuery billing export in their integrated and standard way of monitoring billing. As opposed to BigQuery data export, this billing report is automatically generated and is found in the billing section in the Google Cloud Console. Now, we still recommend that BigQuery billing export and custom dashboards is the best practice for detailed cost tracking and chargeback purposes because they allow you a more customizable and a more isolated approach into how you're looking at your spend. So the last topic we will cover today might be the most important in terms of billing, is budgets and alerts. So now, before I talk about this, I want to make it very, very clear that setting a budget does not cap API usage. If you reach a budget of $1,000 for BigQuery, the further use of that resource will not be blocked and you will still be charged. Budgets are used to create alerts so that you know how your spending is trending over time. They don't cap API usage based on hitting a budget. Alerts prompt you to take action to control your costs, but do not prevent the use of the service when a budget is met or exceeded. So maybe you do want that feature. Okay, we have you covered. So for final control into how your GCP resources are utilized once a budget is reached or close to being met, we recommend configuring a Cloud Pub subtopic for Cloud Billing to publish your budget alerts to. So if you already have a budget's Cloud Pub subtopic configured, you can reuse it for all your budgets, or you can create a new one per budget. And with this Pub subtopic, you can act on alerts to programmatically take action like shut down resources or disable billing, which in turn can cap API usage. This can also be configured through the Billing Budget API. So in this section, we covered billing accounts, specifically how one links to a project and allows you to use GCP resources. Then we talked about how to visualize costs of resources with exporting billing information to BigQuery. And lastly, we discussed how to monitor and control spend on GCP with budgets and Cloud Pub Sub. So that's it from me. I'll now hand it off to Lauren to take us to the Q&A. Thank you.
Awesome. Thank you both for that presentation and some of the demo walkthroughs. So if you don't mind hopping to the next slide, I think we just have a few resources to share with you. So first at the top, again, is that Google Cloud community link. This is where you can engage with each other and with the Googlers on questions and forums. And this is also where we will be posting the recap post from this event. So stay tuned. If you're not yet a member there, I definitely recommend it to stay up to date and engaged with us and to know what's coming up next. And with that in mind, we do have a couple of other events coming up with our technical account management team, including our next session on cost optimization best practices specifically for BigQuery, and that's on March 7th. So we'd love to see you there. You can check it out at that GCC-cloud-events link. And then lastly, we'd love to hear from you how you felt about this session, other topics you want to see in the future, additional questions you may have. So please use that event feedback form, and we would love to hear from you, and we can drop that link into the chat as well. Okay, so we did get a few questions in the chat, and we also have some pre-submitted questions, so we'll go through those first. So our first question that we received was, if we create a folder under an organization using Google Cloud Console, then how can we connect that folder with Terraform and then create a project under it using Terraform?
Yes, thanks, Lauren, and thank you for this question. You can connect the folder that was built through the Cloud Console with, with the project that you would create in Terraform. So you can create a Terraform config file that will specify your new project name and then the existing folder ID under your parent organization. And once you've added that to your config file, you can initialize that with Terraform init and then Terraform apply to really apply the changes in that config file and create the new project under the folder ID that was already created. And we can also, and Lauren, correct me if I'm wrong, we can also share the syntax in the blog post for the exact, the command syntax that the user needs.
Can do. Awesome. Thank you.
Awesome. And actually, we just want to add one more thing. You can look up that syntax on the registry.terraform.io page under Google project example usage as well. Back to you, Lauren.
Perfect. Yes, and we'll be sure to share these resources in the community later on after we close out today. And yeah, for any additional questions you have, feel free to use that chat. Okay, so the next question we got was, what IAM roles are required to create a project in console when we get this error? Google Cloud Platform Service has been disabled. Please contact your administrator to restore service. One way I saw was to enable the check to create projects in admin.google.com, but why do we have to go enable it, and why not the IAM roles come in rescue regarding this issue?
And I will take that one as well. That's a great question. I think the error that is seen here is that Google Cloud Platform Service has been disabled, and then please contact your workspace administrator to restore service. This would essentially mean that the user that's trying to access the service is in a Google Workspace domain, and the domain administrator has not enabled Cloud Console. And looking at the fact that you have admin.google.com, so you are probably the administrator of the Google Workspace domain as well. So then you go to your admin console, you go to apps there, and then check for additional Google services, and then look for the service that says Google Cloud Platform and enable it. IAM roles, they will come into picture once the platform service itself has been enabled by the admin, and it's just a permission issue. So for that, if you see an error like you may not have permission to create projects in this organization, that would mean you're lacking an IAM role, or it's a permission issue and you're lacking the project creator role. I hope that clarifies. Lauren, back to you.
Got it. Awesome. Thank you. All right. Our next question is, I'm attempting to configure Workforce Identity Federation. I've done all the necessary setup. However, when I attempt to perform any workforce pool operations, they fail with a resource exhausted error. I'm attempting to configure this feature because I want to test it with various open source packages I develop and maintain. I'm using a self-service GCP organization with basic support and don't have a formal relationship with the Google account team. So what is the best way for a developer like myself to get access to this feature for development and testing purposes?
That's a great question. Again, I think others would be facing, this issue as well. So just for everybody, who's listening to this webinar, Workforce Identity Federation, it allows GCP customers to seamlessly use the existing IDPs, identity providers, to access GCP services without the need of cloud identity provisioning. And you are right, you will see this resource exhausted error. This rejection is expected. We do enforce abuse protection. So currently, there is no broad-based access, and it's limited to some high reputation organizations. But what we can do is, as an exception, reach out to you after the webinar and see if we can grant the Workforce Identity Federation access. But the broad-based access is something that's not available right now. Lauren, back to you. I hope that answers the question, and if others are seeing this as well.
Awesome. Makes sense. Okay. How can I see all the permissions I have as well as roles on a project using the gcloud command?
Okay, yes. Yeah. If you're looking at the project level, you can use the gcloud command, gcloud projects get IAM policy, and then your project ID. This should list all the roles in your project along with the users and service accounts that are tied to it. And then from there on, you can use gcloud IAM roles describe. For example, you're looking at roles/bigquery.admin to list all the included permissions that are tied to that role. So the way we look at listing permissions is in the context of a role it is bound to, and then the resource to which it is applied. And additionally, I would say also take a look at cloud asset inventory. You could do other things, like you could use it to analyze things like who are granted a given permission in your org. And it has some additional features that would be useful for the organization. And we will add these 2 commands in a blog post as well. Lauren, back to you.
Great. And we're just dropping a link to the asset inventory information in the chat. Awesome. Moving right along. So a couple questions in this one. It looks like how to restrict resources of specific types using a custom role in a GCP project. It looks like the GCP custom role only restricts CRUD operation on GCP resources like listing, creating, deleting, and updating resources. There's no option that storage of size 10 gigabytes is allowed while creating a bucket. How do I apply this type of restriction to a custom role in IAM?
So I'll go ahead and take this one, Lauren. So the first part of that question is you would do an action like this through organization policy constraints, as we discussed earlier in the presentation. But for their specific request to restrict bucket uploads to 10 gigabytes, Google Cloud Storage does not allow for this type of constraint on an object upload size directly within the Google Cloud Console or the command line interface currently. So I can share that there's a publicly available feature request out for this functionality to be added in the future. But for now, there is a workaround. So what this user would do is to limit any uploads to whatever size that they want, is to only allow uploads to their bucket through an HTML form. So by using this, they can create a policy document that goes with this form that will have to be, this policy will have to be met every time that there's a bucket upload. So the HTML forms utilize the XML object post API, and upon a successful upload, user will be returned an XML document with the details of the uploaded object. Hope that answers the question.
Awesome. Thank you for that. I think we have just a couple more. So our next one is, I have 2 projects that I want to migrate. They currently have no organization, and now I want to move them into an organization. How can I do this?
Yes, and I can take this one. You will need to follow a few steps. This is possible. You can migrate a project that is not associated with an org resource into an organization resource. And we do see this, with customers that are just getting started. They just start without, like building their organization hierarchy, and then just start with projects and workloads, and then want to set up a, governed organization hierarchy. So it's a common scenario. So to migrate a project into an org resource, you will have to follow some steps. You will have to first verify the impact of this project on the policies that it's going to inherit in this new org. Then you can, this is optional, but if it's desired, you create a dedicated import folder in the destination org resource. Then you assign some IAM permissions for the project and the destination parent. And these are going to be your project IAM admin role on the project that you want to move. Then your project mover role on the project's parent resource. And if the destination is an organization, which in this case it is, you will have to assign the project creator role on the destination resource. And note that when you are assigning these permissions related to cross-org resource migration, you need to have the same principal email address in both the source and destination org resources. So you can do all this, and then when you're doing the actual migration, you can perform that with a gcloud command or the console. The gcloud command that you would use here would be a gcloud beta projects move project ID / organization ID. Here the project ID will be the project you wish to move to the resource, and then organization ID is going to be the ID of the org resource to which you wish to move this project to. This is detailed really nicely in our public documentation, so we'll share the link for migration there as well. And Lauren, back to you.
Great. Thanks for that detailed response. All right. Every month, all billing contacts on our account get an email with a statement, which is basically a single figure covering all services across all projects. There is a billing report, which we can access via the console, that breaks down our monthly spend into a per project costs. This is perfect for us, but I cannot see any way of automatically generating this into an email for our billing staff every month. Is there a way to do this?
I'll take this one. So based on this question, I'm assuming we have a single billing account that is linked to all the projects. So this is a great example, as we discussed before, on when to use BigQuery in tandem with Cloud Billing to get a clear picture of organization spend on GCP. So to start, I want to discuss what the user is requesting and why we don't recommend it. So this user could send a link to the Cloud Console Billing Reports page directly to all their organization's billing contacts every month. But this isn't really the preferred method, as it would require having each one of those contacts to be a member of the GCP organization with the billing accounts, get spending information, permission enabled. And additionally, a member of one project may not need to see the spend information for another project. So since this approach doesn't practice the principle of least privilege, as we discussed before, it's not recommended. Now for the recommended approach. So we recommend completing this task with exporting your billing data to BigQuery. So once there, you can run queries against the exported table to extract the relevant information for each team, and then send the information off to the billing contacts assigned for the project or team or whatever have you. So this approach is preferred as it's entirely customizable and follows the principle of least privilege by not allowing people outside of one project to see the spend information of another project. And if you want to automate this task, you can even do so with Cloud Scheduler in tandem with Cloud Functions to trigger a job every month that exports the billing data to BigQuery and performs the queries that you decide best suit your needs. And this whole process is very well documented. Thanks, hope it answers your question.
Awesome. Yeah, and would love to see that documentation so you can go through it yourself. And as we've been mentioning, we'll include it in that recap post. So thank you. I think we just have one more pre-submitted question. All right, this looks like a long one. I have an organization in Google Cloud Platform, and we're trying to move other organizations and projects from a different one to a new organization. The previous owner suggested me to go to IAM and admin, identity and organization, or identify an organization, and then migrate projects and billing accounts where I can request project or billings account. Problem is that migrate projects and billing accounts is not even visible at my side. Also, the title is just called identify, not identify an organization. Also, at their end, the title is called identify an organization beta. So I'm now quite confused. Is that because I'm missing a role, or is that because it's only accessible in beta? If so, how can I enter in beta as well?
So that was a long question, but we have a little bit of a concise answer for you. So for those who may not be aware, Google Cloud is currently introducing the organization setup wizard. So as mentioned, this feature is currently in beta and is designed to make it simple for users to establish and delegate administration of their organization's resources. And it also allows them to migrate existing projects to billing accounts into a new organization's resource. As to why this user can't see that, this is an example of discrepancies that may occur when two users do not share the same IAM roles or privileges. So there are two ways to access this tool. The first is the user has to be an owner or editor of a project, as well as a project creator. And then they can migrate projects directly. The second way to access this tool is if the user is an organization administrator, and then they need to request access from a project owner to migrate that project into their organization's resource. So those are the two roles that this user might need to look into and get access to this tool. And now, although this is a beta feature, this tool should be accessible if the user is granted these proper IAM roles. And the last thing to note is that there is a very detailed documentation for all of our GCP offerings and tools that can answer most questions related to IAM permissions and roles that can be used to answer questions pertaining to which IAM roles are necessary to use a GCP resource or tool. Usually when I need to find out what exact roles are needed, I look up the tool or the resource or tool, and usually in the first couple of paragraphs, it'll tell you exactly which IAM roles are required. Hope that helps with your question, and I'll throw it back to Lauren.
Awesome. Thank you both. Okay, so we did get a few questions in the chat. So one that we did answer in the chat, but perhaps there's, if there's anything you would like to elaborate on here, but it is from a data residency perspective, would an organizational policy allow me to restrict resources where my users can deploy resources to a specific geographic area, such as US regions only?
And yes, I think we did answer this a bit, but we do have a organization policy constraint that allows you to do exactly that. You can limit, and we see this specifically with GDPR coming in Europe and other data residency requirements that you need to keep your resources in a certain location. So we do have that constraint, and it is constraints/gcp dot resource location. So you can use that and set that to make sure your data residency requirements and your resources are physically spun up in some specific GCP locations and not everywhere, which is by default, which is the default scenario.
Awesome. Okay, another one is, you mentioned that it's important that billing is not disabled to avoid any impact on your resources. So is there any best practices or recommendations that you have to avoid any potential impacts like this due to billing being shut off or disabled?
Yeah, I mean, we can add, this is a bit generic, but usually billing from Google Cloud side, if you violate some terms of service, your billing account may be shut off. This is to protect the platform from fraud and abuse. Or if you're not, and of course we have long-standing relationships with customers. So if you're not paying your bills on time, we reach out. It's not like we'll just shut off your billing account. There are customer service people at GCP that will reach out and work with you, and just to make sure that we are accounting for any delay on your end as well. But other than that, you could look at some of the things that Cris did cover in his session. Is you can monitor your usage, you can look at alerts, so you'll be notified when you're reaching a certain level of usage or spend. You can create certain budgets for each service. You have cost management tools that we can link in from GCP as well, that you can use. So all of these would really help you monitor your spend, but to make sure that it's not disabled as such. It's all about just making sure we are within the terms of service. So I hope we answered that question.
Yeah, that sounds good. Yeah, if there's any additional clarification you're looking for, please feel free to add that into the chat now or into the community, and we can expand on that if there's more specifics you have. Okay, I think that addresses all of the questions that we had. So if you do have any additional, feel free to add into the comments area of this YouTube video or into the chat, and we'll be collecting those and including it in our event recap post. And then as a final reminder, we do have that feedback form. So if you have a minute, we'd love to hear from you, future sessions, what you thought about the one today, what topics you'd like to see in the future, etc. So we really appreciate your feedback there. Any final thoughts from you, Kamiya and Cris? Just want to say thank you so much for being here today and for sharing this information and your expertise with us. And we hope to see you again at another time. But any final thoughts before we close out today?
Thank you so much for having us, Lauren. And this is a great session, and hope there were some key takeaways that everybody took from this session. But thank you so much for having us. Cris?
Yeah, ditto. This is fun. Had a great time. Thanks for having us.
Awesome. Thank you, everyone, if you stuck around for the time, and we hope to see you next time, and we'll stay in touch in the community. Thanks.